Hola, buenas tardes. Mi nombre es María Alicia Loray y en nombre de todo el equipo de VITAGEN le damos la bienvenida a nuestro segundo webinar y auspiciado en esta oportunidad por SAEC, la Sociedad Argentina de Biología Clínica. Así que los esperamos, vamos a compartir hoy el tema que nos convoca, que es la micromanipulación y aceites en la fertilización in vitro y el trabajo en equipo. Durante el webinar vamos a desarrollar los siguientes temas: la complementariedad de los procesos de la fertilización in vitro y la mejora de los resultados, los medios de la micromanipulación, aceites, características y su uso también en cultivo. Y en una segunda parte vamos a tener las sesiones preguntas y respuestas, donde ustedes van a poder hacer todas las preguntas y comentarios que crean pertinentes, que quieran compartir con nosotros y con el resto de la audiencia. Hoy, en esta oportunidad, a cargo de la charla en estos temas, la vamos a tener a Lisa Wagner, que es una técnica experta de la empresa Fujifilm Advanced Scientific, de la cual tenemos el honor de poder representar en el país. Hi, Lisa.
Hello.
Welcome to this webinar. Hello. And welcome to Argentina, in a way to say. Well, I will introduce you to the audience, but I will do it in Spanish, so you wait for me, and
yes.
Then we are ready to start your presentation, yes?
Sounds good.
Okay. Bueno, Lisa ha sido una embrióloga durante 23 años ejerciendo la profesión. Tiene experiencia en todos los aspectos de la embriología, andrología y endocrinología. Tiempo atrás trabajó en el diseño de un laboratorio de fertilización in vitro en Florida, al cual luego ha dirigido y trabajado como responsable de todas las operaciones de dicho laboratorio. Lisa tiene una licenciatura en tecnología médica y una maestría en ciencias clínicas reproductivas. Próximamente también Lisa va a iniciar estudios de doctorado ya en agosto de este año. Lisa además es supervisora técnica tanto en embriología como en andrología, certificada por la Junta Estadounidense de Bioanálisis. Como especialista técnica de Fujifilm Advanced Scientific, Lisa es la responsable de todos los productos de reproducción asistida. Ella imparte talleres prácticos y conferencias en diferentes ámbitos a nivel nacional como internacional. Capacita a distribuidores y clientes, ayudando en la resolución de problemas y en la mejora de procesos de laboratorio. Durante los últimos años, Lisa también ha sido instructora en programas de maestrías. Bueno, Lisa, como verán, tiene una vasta experiencia en todo el tema relacionado con la fertilización in vitro. Así que, bueno, ahora los voy a dejar con ella para que ella les pueda presentar su charla. Y les recuerdo nuevamente que luego vamos a tener la sesión de preguntas y respuestas. Vamos a tener dos embriólogos invitados, que luego los voy a presentar a cada uno de ellos, pero que les adelanto que son Cristian Álvarez Cedó y Ignacio Moreno. Así que luego haremos las presentaciones respectivas de ambos. Bueno, los voy a dejar con Lisa, ¿sí? Lisa, we are ready to start. The audience is yours.
Thank you so much. Thank you so much for having me here today. It's great to be here to be able to talk with everyone. We're going to talk today a little bit about micromanipulation media and oil and kind of how the IVF process works together from the lab perspective. So many things we do in the lab work together. One of those things that today, obviously, we're going to focus on is micromanipulation media and oil. And while both of those things are very good on their own, they help each other when they work together. And everyone's goal in the lab is to improve outcomes. And so by using oil, particularly both in culture and with micromanipulation media, we are improving our outcomes because it takes less stress on the embryo as we do the procedures that we need to do. So we're going to talk a little bit about the embryo environment. And so obviously when it's in the incubator, that's all very good. But there's plenty of times we have to have it out of the incubator. And so some of the things we worry about, we are all very protective of our embryos. And so we have to constantly worry about temperature, pH, osmolality, and we need a barrier on the culture system to kind of protect our embryos. And oil is that barrier. And so there's many things we do in tandem to help keep all of these things stable. And that's all of our goals in the lab, is to do the best we can for our embryos. And when you look at the life cycle of culture, you know, in the incubator, that's where all of the growth is happening. And that's where the embryos are most protected. They have a stable temperature environment. They have a stable pH equilibration with the CO2 in the incubator. They don't have to go through any kind of stress. They're very steady in their environment and in their growth. However, all of us know that there are many times we have to take the dish out of the incubator. This is for insemination, whether that be standard IVF or whether we're doing ICSI. And then along with that comes you have to strip your eggs. You have to, you know, check your maturity. You have to know what you are ICSIing. Then again, you take them back out the next day for fertilization checks. Many labs will still check on day 2, day 3, day 5, day 6, day 7. All of these growth checks have to, some clinics still want to know every single day. Now, some have taken those away. Some will only check on day 3 and day 5 and 6. Some clinics don't check day 3 anymore. If you're only doing day 5 blast transfers, then many people will just let the embryos grow and not take them out of the incubator. There are pros and cons to both. Obviously, patients typically want to know how their embryos are growing, and they want to know, kind of set their expectations for their transfer days. And that's always a balance routine between the doctors and the nurses and the patients versus what we know to be best for the embryos. So that's usually a constant struggle. The other thing, regardless of when you check growth, you have to prepare the embryos for transfer. They are out of the incubator again. Certainly, if you are doing biopsy, they are out of the incubator and can be for more of an extended time. Certainly, vitrification, when you are finalizing those steps and you have them out of the incubator again, not only to check which embryos you are going to vitrify, but also then actual vitrification. So the embryos are in and out of their best environment quite frequently. And so our goal is to, again, minimize stress so that we're doing the best we can with the embryos. And so many things in the lab will work together. And that's how we can increase our outcomes for patients, for the docs, for everybody. So there are things that, say, sperm prep media works with insemination media, and you have to use those things together. Oil and micromanipulation media certainly work together. Oil and culture media work together. And so there's many things in the lab that work as part of a system. So we're going to talk about a few of them today. So for ICSI, for instance, we're using very small volumes, and even in culture. So this obviously is more of a culture drop dish, and they are covered with oil. Even if they are inside a humidified incubator, at least here in the States, I don't know of anybody who is not using an oil overlay. So oil is protective. Oil is protective inside the incubator. It is even more so outside of the incubator. So that's why we have to be aware of what we're using and why we're using it. So again, for culture, we have very small volumes of media. This media would not only start to evaporate, which is certainly going to change our osmolality, which would not be good for embryo growth. So we cover it in oil to protect it. So the thing you can do when you are going to be out of the incubator for an extended period of time, you would use a different media, a non-CO2 dependent media. This way, you would still use oil for the same reasons, but now you don't have to be so concerned about the pH drops. And we will get into that in just a minute. So the media that you would use for micromanipulation is media that CO2 is not required. This is a media that has a different buffer system. Typically, they are zwitterionic buffers, which means they can act as either an acid or a base. They can donate or accept protons in order to keep the pH stable. So there are many, many of these available, but we need them to be at 37 degrees physiological temperatures, and we need to work at the pH of around 725 to 730. Because that's what works best for our culture system. And so each buffer works in a different way and has a different ability at different temperatures and different pHs where it works best. And this is simply a mathematical equation. If we go back to even what pH is, I did not go into this here, but you probably all remember your chemistry, the Henderson-Hasselbalch equation, which is how you find pH. Well, part of that is pKa, and that is the log of the acid dissociation constant, which is Ka. And this is a number that will tell you where you have optimal buffering capacity. This is a state in which this buffer, you have equal amounts of acid and conjugate base in solution. And the reason you want to know this is because this is where you have your highest buffering capacity. It's your greatest ability to resist pH change, which is what we're looking for, particularly when we are out of the incubator. We don't have CO2 to add in, obviously, when we're outside of the incubator, so it must work in room air. This is a different system than the bicarbonate buffer system that does require CO2. So we're going to focus on these zwitterionic buffers right now, just because we're talking about use outside of the incubator. Now, I'm sure these will both sound very familiar. These are the ones that are used all over IVF, are HEEPs and MOPs. And just to show you why they're used. So now let's talk about the pKa. So the pKa of HEEPs at 37 degrees is 7.31. Well, that's exactly where we're using it, right? We want our embryos to be at 37 degrees. HEEPs has a really great buffering capacity at 7.31. That is why it is used in IVF. And so that is why when you have a lot of sperm prep medias, things like that, are HEEPs buffered because of this pKa. But I also want to talk a little bit about MOPs. So MOPs has a pKa of 7.15 at 20 degrees, so room temperature. So the interesting thing about that is when you are, much of what we do is warmed at 37, either on a 37 degree bench or even on your inverted scope, the stage is heated to 37. But that's not quite as efficient as an incubator, where everything around is 37. There can be fluctuations in the temperature. And so the bonus of using a MOPS buffer is that it works better, it has a better buffering capacity at room temperature. So 7.15 is very close to 720, which would be kind of the bottom end of where we would want sperm and embryos to be. And so the bonus of MOPS is it works better at room temperature. The bonus of HEEPs is it has better buffering capacity at 37. And so just to explain, that is why these two buffers are very commonly used across the board in IVF, because of this pKa determination and the temperatures and the pHs that we are using in the IVF lab. So just to talk a little bit about our particular products, so we have two actually that would be used as a micromanipulation media, apologies. So modified HTF on the right side is a HEAPS buffered media. This was one of the very first IVF media that became commercialized. It's been around a long time. A lot of people use it. Has HEAPS buffer, so works very well at 37 degrees. But they developed something very recently called multi-purpose handling medium, and that's on the left-hand side. And the biggest difference between these two is MHM media has both HEAPS and MOPS, which means MHM will have a better buffering capacity across a wider range of temperatures. So for instance, I will tell you, for everything I'm going to talk about, both media work. However, when you are looking at a purely scientific pH, pKa buffering capacity, MHM will work better when you are going across room temperature versus 37 degrees. And what I mean by that is when you are, let's say, doing your sperm preps and you need a media that's to be used outside of the incubator, and sperm is certainly kept at 37 degrees. However, when you have it out of the incubator and you are centrifuging, it's going to become room temperature. And so that is an added bonus of the MHM media, is that it has that extra buffer in there to cover all the buffering capacity necessary at room temperature, as well as 37 degrees. Now, that having been said, I will tell you, even for me, for years when I was on the bench, we used modified HTF to process our sperm. It does work. I'm just trying to point out that with the scientific studies behind both buffers and the reasons why they buffer differently at different temperatures is just something to keep in mind, that you will get better buffering capacity across a range of temperatures with the MHM media as opposed to modified HTF. So let's talk about the oil then for just a little bit. Oil is always used as kind of a cap. So you have, whether it's your culture dish and your culture media, which as we discussed are typically very small droplets of media, even in a humidified incubator, they will start to evaporate, which will change your osmolality, which can then change your pH. And so you want to protect those embryos. So during culture, oil will protect from any impurities in your incubator. So if any kind of chemicals get in there, if you cleaned your incubator with an improper cleanser, the oil will help protect the media underneath it. Now, is it 100% absolutely not going to get in there? No, it's not that good. But it increases the amount of time for things to travel through the oil to get to your culture media. So it is a good barrier, definitely for humidity going out and evaporation, as well as impurities that could possibly get in. And so that's the second line. It does reduce evaporation. It will maintain the osmolality of your culture media inside the incubator. And therefore, because all of those things are happening, it is also helping maintain your pH when it is out of the incubator. Because oil is acting as a cap, humidity and things do not escape the culture media as quickly. And so even when those few times you have to take your culture media out of the incubator, whether that be for fertilization checks, whether that be for day 3 checks, it is far more protected with oil on it than just culture media drops would be. Your pH would change almost instantaneously when you take it out of the incubator, as well as evaporation starts, everything. So oil is protecting during culture. During micromanipulation, it is also protecting, but in a slightly different way. So this is definitely going to help maintain temperature. If you have made your, let's say, ICSI dish and you've got oil on it and you put that on a 37-degree stage on your inverted scope, the oil will help protect that 37 degrees. It will help keep those the culture media, micromanipulation media, drops at temperature. It does also, in the very same way, reduce evaporation and reduce, which will maintain your osmolality, which is important even in non-CO2 media. You do want to keep the media as solid as it can be. All of those changes are not good for the embryos you have in that drop at that time. So we'll talk a little bit about the molecular makeup of oil. And so oil is simply a liquid solution of hydrocarbons. It consists of alkanes, which are simply saturated carbon and hydrogen molecules. It is distilled from petroleum, and that's just how it's made. So I will tell you that I hear commonly about paraffin oil versus mineral oil. This is an interesting topic because as I was researching for this talk, actually, most other fields do not recognize a difference between paraffin and mineral oil. So typically, paraffin oil is linear alkane molecules, with isoparaffin being branched chains alkanes, and mineral oil is a combination of branched and cyclic alkanes. Now, I am not a biochemist or an organic chemist. That doesn't seem like a huge difference to me. I know there are studies out there and there are other companies that promote a big difference between paraffin oil and mineral oil. But when you look at the very core of how they are made and what they are made up of, they're very, very similar. And I do realize that there are a lot of perceptions in our field. You know, many people do things because they always have. And I completely understand that. Been in the field for 23 years. And when something is working, you do not want to change it. And I understand that. But getting to the core of what really is the difference between these two, quote, types of oil, there doesn't seem to be a whole lot. So I think it's one of those ongoing studies, and people are still studying the differences between paraffin and mineral in as far as results and blast rates and things like that. And I don't think there's an absolute sure one is better than the other. I think it can work differently in your lab as compared to someone else's lab, much the way continuous media versus sequential media. There are people on both sides of that argument, and neither one is wrong. And so it's a matter of finding what you like and what's working in your lab. But just to show you the differences and the very, very subtle differences that are between the two, I wanted to point that out. So Irvine oil is light mineral oil. And mineral oil is, again, just kind of a more general term for the kind of oil that people are using. It does refer to the density and viscosity. So there are different manufacturers that have different viscosities of oil. Again, I very much believe that is a preference situation. I don't know of any study that has come out that absolutely heavier oil is better than lighter oil. I know some people like a little bit heavier oil because it doesn't splash around in your dish, which is certainly important. But I can tell you I have participated in experiments of the quote light versus the quote heavy oil. And it's so, on a blind study, even after having been in the field for more than 20 years, I could not differentiate. So again, it's one of those things that's the way you've always done it. That's what you like. That's what works in your lab. Absolutely do that. There's no clear right or wrong here. like so many things in our field. So, but just to point out what's really going on behind all of that. So our media is, or our oil, I'm sorry, is light mineral oil. And just so you know, the density and viscosity is defined by the average chain length of the hydrocarbon molecules. That's where that comes from. And that's what gives us the different viscosities that people like. So just to sum up, this is kind of how things work together. Many things that we do in the lab are complementary. Certainly oil is complementary with culture systems. It is definitely complementary on the micromanipulation media, and kind of how we're using them and why we're using them are really, for the most part, the same. There are a few differences in what you're trying to protect from, whether you're in incubator or out of incubator, but the idea is the same behind both. And so clearly we're all trying to improve our outcomes for our patients, of course, but certainly for the doctors, the nurses, the lab, everybody wants to see everyone do well. And so anything we can do to maximize each step, that's why we come across with these things and decide how to best work what we need to do. We have to take these things out of the incubator. We have to know what they're doing. We have to look at them. And so that's how this all started, was the oil is a very protective mechanism, both culture and micromanipulation media. So, and that's the extent of the PowerPoint. I know we have some people here and some questions. And so hopefully we can just spend the rest of the time kind of talking about what's important. Other people can add their experiences and expertise. I think in this field, that's always the best thing to do, because everybody has a slightly different experience and everybody may have something slightly different that's working for them. And it's important for us to continue to share that and learn from each other. So that's all I have prepared. We can go from here.
Okay, Lisa, thank you for your presentation. It was very interesting, and I think it's easy to follow and to understand. So thank you again.
You're welcome.
Okay, and then we are going to the second part of this webinar, that is the question and answer. And we invite the people to leave their comments or questions that they have. And I will invite now the two embryologists that will be by us today, just to share this part of the webinar. Hello, Cristian Álvarez-Sedó and Ignacio Moreno.
Hola.
Now I will continue in Spanish just to introduce both, Lisa, and then we can play together with the questions and answers, yes?
Okay.
Ok, bueno, bienvenidos a los dos. Los voy a presentar, aunque ya la mayoría de las personas que nos van a estar escuchando los conocen, pero bueno, vamos a hacer un resumen un poquito de cada uno. Bueno, el doctor Cristian Álvarez-Sedó es director del Laboratorio de Embriología de Fertilia, especialista en embriología clínica, andrología y genética reproductiva. Es miembro de la actual comisión directiva de SAMER y de la Comisión de Educación de Red Lara. Es director del curso de biología de la reproducción de SAMER también. Y bueno, Cristian tiene numerosas publicaciones en diversas revistas nacionales e internacionales, presentaciones en congresos, participación en capítulos de libros y demás. Así que, bueno, una gran experiencia también en todo lo relacionado con la fertilización in vitro. Y Ignacio Moreno es licenciado en biología, recibido de la Universidad de Córdoba, embriólogo clínico por SAMER, es presidente de la Sociedad Argentina de Biología Clínica, SAEC, es director del laboratorio del Instituto de Fertilidad Asistida Dr. Julio Colabianchi en Rosario. También es director del laboratorio del Centro de Estudios de Reproducción y Fertilidad Humana en Paraná. Y es embriólogo en el laboratorio Genia. También Ignacio tiene diversas publicaciones, presentaciones en congresos y demás. Así que bueno, los dejo. Estamos todos aquí compartiendo esta sesión, pero bueno, principalmente a ellos dos que la van a guiar y vamos a interactuar con Lisa también. Así que bueno, cuando ustedes quieran, si quieren empezar con comentarios de ustedes, si quieren hacer algunas preguntas.
Bueno. Bueno, primero, ante todo, gracias Alicia, gracias VITAGEN por la invitación. De mi parte, un placer participar y bueno, ahora vamos a proceder con Ignacio a hacerle algunas preguntas a Lisa en base a los temas que ella ha tocado y seguramente irá surgiendo alguna de las motivaciones propias del día a día, como hablábamos con Ignacio, que seguramente también va a ser muy enriquecedor para todos los que están escuchando este webinar.
Seguro.
¿Querés decir algo, Ignacio?
Bueno, Alicia, gracias VITAGEN por la invitación. Gracias a SAEC también por ser parte de todos estos proyectos educativos. Lisa, thank you very much for your presentation. It was very clear. It's really important we can talk about these things we normally do in the lab and talk about situations that sometimes occurs in the lab, and we kind of hesitate how to resolve them. Like, I don't know, for example, let's say I prepare 4 ICSI plates, but in one case is canceled. So can I keep that ICSI plate for the day after, or where should I place it, in the fridge or leave it at room temperature, for example?
So if at all possible, I would just make new ones the next day. However, I understand sometimes there are times where it's very limited sperm, whether it be Tessa or whether the patient just had a hard time collecting. I would still be very careful about that. And there are, I can tell you, mixed feelings on that. When we in my lab had sperm that we had to hold on to, we actually kept it at room temperature because the metabolism of the sperm then slows down. And so any metabolic waste products were decreased in the amount of time. At 37, they will be moving and swimming very quickly. And so in order to slow that down and to slow any waste products, we would leave it at room temperature. So if it's a case where you absolutely cannot get more sperm, or this is the only sperm you're going to get, my recommendation would be room temperature until the next day, and maybe put it into, if you can, depending again on what your count is, how many eggs you have, pull them out of that media and put them in fresh, just as one of those things where you want to cover all the bases.
Okay, but just speaking about the oil and the media, it has something to worry about, or just don't?
Yeah, I don't think so. Our media is made to be kept at room temperature, stored at room temperature even before it's opened. And if those were eggs or embryos, I would be much more concerned about them not being at 37. But sperm, I would not worry too much about that. So,
okay.
Christian, do you have other experiences?
Well, hi, Lisa.
Hi.
Hi. Thank you so much for your kind presentation. It was very, very great to hear you ask here. Well, I have a question regarding the oil. But first, I would like to ask you about the media for handling oocyte and sperm for ICSI. There are some reports about that the people use non-HIPS buffer media to perform ICSI because they say that this kind of media is better for the oocytes. But the problem is that you don't have so much time to do the ICSI because the pH is going to start to change. But on the other hand, you have people like you are like us that use media with HIPS. But the problem is that it's not the better media for the oocytes, probably. But you have enough time to work easy, listen to music while you are doing it, So, in your opinion, what is the decision point? It depends of the sperm sample quality, for example, of the number of oocytes. If you have to decide a media with not HIPS or a media with HIPS.
For ICSI, you're talking?
Yes.
So I agree with you that culture media is better for the embryos. but it's only better when it's at the right temperature and the right pH. There are a lot of studies out there by Joe Conahan, Jason Swain, Rusty Poole on pH shifts for bicarbonate buffered media, which is culture media, when it is used outside of an incubator. And even with an oil overlay, an oil cap, you have 10 minutes maybe at most before your pH is starting to change. So with no oil overlay, it's within a minute and it's just out of range. So you do have 10 minutes is kind of the standard that I saw in several different papers. So for me personally, I would probably feel very pressured and rushed to get an ICSI, even if you say you have 20 eggs, you know, to leave that dish out. Because even if you didn't put all 20 eggs into that drop, you're using that drop.
Yeah.
Now, if you wanted to do, you know, depending on your level of experience and skill, you could make 5 different drops and have, you know, so 4 eggs per drop and change dishes every 4 eggs. If you wanted to do that and you're very aware of temperature and pH changes that are occurring, I think you'd be fine to use culture media. Mm-hmm. Most people that I talk to kind of have especially if you've got 10 ICSIs in one day, you have to make your drop, you have to get your ICSI done, and you have to move on. You wouldn't have time to do all of that. So I don't think that using a HEAPS or MOPS-based buffer media is so detrimental to the eggs or embryos that it shouldn't be used. I think, again, you have to come back to what is working in your lab. How fast are you? How many eggs? How good is your sperm? You know, yeah, there's so many variables that it's another one of those kind of critical thinking decisions that we all have to make 100 times a day, because there's absolutely no black or white in this field. It's so dependent on so many things. That's why I always think it's important to know why you're doing what you're doing, because then you can really make an informed decision on what is going to be best for you, for your lab, for your patient, and kind of go from there.
Perfect. Mm-hmm. Thank you.
Yes.
Lisa, is there an optimal preparation time for ICSI plates? For example, I can prepare them at the very first early morning, or half an hour maybe earlier of ICSI?
So again, I think it would depend on which media you're using and how good is your sperm. So in my experience, especially with absolutely normal good sperm, I like to make them right before I ICSI. And the sole reason being that they don't have too much time. So for too many sperm to swim out of the PVP, it makes for an easier ICSI for me if you have fewer to choose from that have. So I always make my ICSI drops a long drop of PVP. I will inseminate it down here and let them swim upward. So if they only have a few minutes, by the time I pick my sperm from up here, it's very easy to do. And if you let them go for hours and hours and hours, they would all swim up. And so then you're picking 2 sperm out of 100 sperm, which is much more difficult. That having been said, if you have abnormal sperm and you want to give it more time because there's either very few there or very few that are motile, you could set it up in the morning. If it's, again, you have to kind of think about how many sperm do you have? How motile are they? What percentage of PVP are you using? How fast are they going to swim up into the PVP? And you kind of have to judge, you know, how you like it. Do you like to have 100 to choose from, or would you rather only have 10 to choose from? And you can adjust timing and everything based on all of those things.
I am agree.
Okay.
I was thinking about, for example, like you say, you have 10 ICSI in a day. So the ICSI plate preparation may be a useful tool without putting the sperms, right? Without putting the sperm right into the plate. So if there's something that we might consider before preparing 10 ICSI plates and then putting the sperm to afterwards, right? afterward put in the...
I see. That's a good question. So we go back to temperature and pH. So as long as it was going to stay at 37, because even though your eggs will be in there for a very short time, they will be in there. So you would absolutely want to make sure that it is staying at 37, regardless of whatever time you decide to make them up. And, you know, if you're using a heaps or mops based buffer system media, you would certainly have far more time. I guess I would, for my own well-being and my own knowledge, I would want to know, okay, if I was going to set them up 5 hours early, I would do a test and set something out for 5 hours and then test the pH and test and make sure that you are within the range that you're looking for. Because we can tell ourselves, oh, it's going to be fine. It's heaps buffered. It works great. But until you actually know that, we're not seeing the damage that we're doing. You still may have perfectly lovely eggs, perfectly good fertilization. They could divide and even make blasts, but we've all seen beautiful blasts that are abnormal. And so I guess I feel like I always want to do everything I can to make sure everything is the most normal as possible for those eggs and embryos. So I wouldn't just do it and pick a random time. I would confirm in my lab what my dish is in the pH and the temperature for whatever time you have decided to make them early. Does that make sense?
Yep. Thanks.
Okay.
Lisa, about the differences between oil and paraffin, you have already said that, in your opinion, there is not quite differences between them. But there are some new reports. There is a recently paper published in Nature that says that they have studied the embryo development between these two kinds of oil overlapping. So, and they discovered that in this case, the embryo development to blastocyst stage was a little bit worse in mineral oil in compare with the paraffin. But they measured the peroxidation levels between those oils and paraffin, and they didn't find any difference. But when they started to look the VOC in the oil, they find differences, and they try to understand maybe this kind of situation will be not good for the embryos, because this VOC can be transferred to the culture media and affect the embryo development. So, do you know something about the VOCs in the oil and how we can handle with this?
So, VOCs is another interesting thing. So it's even defined differently by country what they consider a VOC. So it is things that typically are man-made. These are typically like detergents and paints and, you know, anything that's evaporating out of another substance, right? And so the best way to avoid those things, that's why we don't clean our incubators with, you know, any kind of detergent. That's why we don't use alcohol to clean down the lab at the end of the day, because all of those things are putting VOCs into your air. And so I think the best way is to just avoid them, realizing that that's not completely possible because there are plastic pieces inside incubators. There are, you know, those kinds of things, exhaust that comes into the ventilation system from outside. There are definitely sources of VOCs for all of us. As far as I know, that, you know, what the VOCs that are coming in the oil, my guess is that all manufacturers are testing for that. And, you know, there are certainly different peroxidation levels, those kinds of things. And that's something that when they test at the beginning, you know, they wouldn't put out oil that has any kind of high level of any of these things. So I think it's a matter of, as far as VOCs go, it's not the oil breaking down. It's not something that would be in the oil. It's something that's being introduced. Either in your lab or in your incubator. And so that we should all be aware of that.
Okay. So in that case, you don't need to, you don't think that we have to wash the oil before using, like in some laboratories they used to do?
Yes, I was going to say, so again, that was something from years and years and years ago when I first started that people did. And I think it was kind of a, we don't know what else to do, but we have to figure something out. And so I will tell you, we did wash our oil for quite some time. It made no difference in any of our outcomes. And, you know, as more research comes out, we actually stopped washing. The interesting thing to think about oils are and washing is typically things are water soluble or oil soluble. So if you're washing oil with a water-based culture media, whatever's absorbed in that oil is not going to come into the water-based culture media. So you're doing something and you make yourself feel better, and that's a big percentage of what we do, right? So I'm not against it. It will not hurt anything. But when we get to the question of, is it necessary? My opinion with manufacturing and the level of QC that goes on now, I don't believe it's necessary.
Okay.
Yeah.
Perfect.
Maybe it's mentally necessary.
Exactly. And that's and I would be behind that, because a lot of what we do is just to make ourselves feel better that we're doing all we can. Yeah.
That's right.
I get it.
Lisa, for example, about osmolarity changes, can fertilization be affected by water loss in micro droplets of an ICSI plate that was wrongly prepared?
I would have to think about an exact study that shows that, but if we just think about the theory behind, if you're talking like the ICSI dish when you're ICSIing, so any kind of
I spend too much time between the droplets and the oil coverage, so maybe the water loss there may be affected or not.
I can't tell you 100% that fertilization per se would be affected. However, if you notice when you put your eggs into a drop and they start to shrink, you're damaging those eggs already, and you haven't even ICSI'd yet. So yes, I would say absolutely osmolarity changes are detrimental, whether it's detrimental on a cellular level or a fertilization level or a, you know, all kinds of things that have to happen biologically post ICSI. You know, there are times where you see those things, and as long as you get them out of that situation quickly enough, there wouldn't be long-term damage. But again, going back to that, we're all trying to do the best we can at every step. If you put something, if you put an egg particularly into a dish that you know you made up either quite some time ago or didn't put your oil on immediately, and you notice those changes, I would make another dish, because it's not worth it to me to any possible damage that you could be doing. I mean, you know, you're using a little tiny bit of media. Yes, it's the cost of a dish and, you know, 5 or 10 mils of oil, but to that patient, that could be everything they have. And so why wouldn't we do everything we could to give them the best outcome?
Perfect.
Lisa, regarding the pH, in your opinion, this is, I think, is every laboratory have their culture. So in your opinion, we have to measure the pH of every batch of culture media, or maybe every bottle of the same batch, or also when we change the CO2 cylinder. What's your opinion about that?
So I can tell you, I have been to labs certainly all across the US and even several in other countries. And I have seen everything from people who pH every single day to pH who very literally never pH, and everywhere in between. I think it comes down to your trust in your culture system. You have to look at your growth rates. You have to look at your blast rates. You have to look at your vitrification rate. If all of those things are extremely consistent and you don't pH at all, well, I can't argue with that too much. I guess for me personally, just to be sure, I would probably pH on new lot numbers. just to assure that the next group of embryos are going to be as good as the last ones. I do know some people who change or pH at every CO2 tank change, because there can certainly be differences in those levels. And, you know, actually on that note, I have been to labs where their issue was, the reason they called me was their growth seemed to be kind of all over the place. It would be great for a while and then really be bad and then back up. And so when I start investigating, they are getting CO2 tanks, and let's say it's 5%. But when they pull the order forms for the CO2 tanks, it's 5% plus or minus 1 whole percent. So
much.
Right. And so your pH is already all over the place. If you weren't checking, you'd have no way of knowing that. And so my advice would be always make sure you know what your plus or minus is on the CO2 tank that you're, especially obviously mixed gas is what I'm talking about. Make sure that it's within a very tight range of what you order, or you will have those problems. But that's another reason to then pH at every tank change. Some people do it once a quarter, once a month, once a week. It all depends on your trust in your culture system. And if you remember that pH is kind of a piece of the puzzle. So you have to look, pH is huge, but it's not everything. Is your growth rate good? Is your blast rate good? You know, your FERT rate, all of those things. If those are all good, then you have to kind of wonder, should I change my pH? I don't know. Everything's looking great. You know, so again, it's a piece of a puzzle. So you have to set it for yourself.
Regarding the CO2 purity, in your opinion, which is the purity that we have to work in the laboratory? Because it's a medical quality of the CO2 is 99.99% of purity, and there's another kind of purity. And I know that the pH depends on that purity also. So I think it's very important also to take care about that. No?
I agree. Yeah, you have to know what you're dealing with in order to make changes for it down the line if you need to. Yeah. Now, I will tell you, I have talked to several labs who went to calibration grade CO2, which is plus or minus 0.00001. They told me they hadn't noticed a big change, a big difference in pH at that level, and it's very, very expensive. So from people I've talked to who use that, I don't think that grade is quite necessary, but particularly mixed gas. If you order 5%, you need to know that you have between 4.9 and 5.1% CO2. You know, this 4 to 6%, that's going to fluctuate way too much.
Exactly.
It's quite a thing here in Argentina.
In Argentina,
it's quite a thing to be sure about the purity of the gases.
Oh, good. That's
It's not easy to be sure about that here in Argentina. That's the reason we have some troubles about that. Yeah.
So do you check the CO2 itself, or do you base it on pH?
No, both.
Okay.
Personally, the pH, it's everything. And that this was the other question I was thinking about. It's not the main topic of this webinar, but I'm curious about your opinion. Is the thing about how we measure pH, because we talk about pH here, pH there, but the way that we measure pH it's far different between every embryologist. So personally, I only trust in blood gas analyzers to measure pH. What's your opinion about the way of pH measure?
I would agree with you. pH or blood gas analyzers are definitely the gold standard, as long as they're being controlled, running controls and standards and those sorts of things, so that you know the number you're getting is accurate. Probes can work. And again, I've seen that all over the board, where sometimes they are right on to my iStat. I use an iStat, no affiliation with them. That's just what I use. And sometimes they're right on and sometimes they're way off. And so I would recommend, if probes though are much less expensive. And so, I mean, they have to be cleaned, especially if you're pHing media with protein in it. You have to remove that protein. And most people who are very into pH up here would replace their probe every 6 months or no more than once every year. Completely replace the probe, because once that the tip on the end where the media goes in, once that gets gummed up with protein, and it's not going to be accurate anymore. So that's the problem with those. And there's standards, but there's no controls for those. And so that's the difference. And it's hard to know what you really have.
So, Lisa, sorry. No. Okay.
No, iba a levantar una pregunta, pero dale.
Okay, going back to the oil. I don't know if Irvine have a light or heavy oil, but if you have to, make an explanation, because there is some trends that people says, if we have to culture in a long-term culture, day 5, day 6, maybe you have to use the heavy oil, and for the other things in the lab, you have to use the light oil. Do you think is that correct? Is just this because long-term of culture, you have to use a heavy oil just to, maybe you can think that it protects more than the other one? What's your opinion about that?
It's hard to say. I have also seen papers that are kind of on both sides of that. The other thing I read a lot is more oil is better. Yeah. I don't think that's been proven definitively. It does make sense to me. Yeah. I think the other thing to think about is, do you have dry incubators? Do you have minks or one of those? Or do you have humidified incubators? So it also makes sense to me, if you have dry incubators, you might want a heavier oil or more oil. I don't think it would hurt. The thing to be aware of in those situations, either with heavier oil or more oil, is it does take longer for your media to equilibrate. So, everybody I know, you put your dishes in the night before, but you want to make sure there's at least 8 hours, because especially with the heavier oils, it does take longer for the CO2 to get to the media, for the media to be fully equilibrated for you to use the next morning. So again, I feel like there's been many non-answers here. But
I think that maybe, I don't remember, Jason Swain have a paper, I don't know, that says there is a rate between the volume of the drop and the oil. And I think that you have to use at least 20 microliters or 40 at least, and 5 milliliters of oil in a 35 millimeter dish. Is that correct for you?
Yeah, most people up here will use between maybe 20 and 50 microliters. There are people who are using larger volumes, 100 to 300 microliter drops. The problem with the higher volumes of culture media is you don't get that, they're not in close enough volume to help each other, basically. Why we went to micro drops in the first place instead of large volume. So if your volume is too large, you're not really getting that kind of co-culture system. So there's a fine line between all that. And yeah, Jason Swain has a lot of good papers on pH. The other thing is the surface area of your microdrop, not only your volume, but the surface area. If it's spread very flat, it takes, you have more area and all of that. So again, it's one of 100 variables that what you're doing in your lab. And I would recommend that you always know, like test it in your lab, what you're doing and what you're using, so that you can be assured that you're doing everything you can. What works for Jason Swain in his lab may or may not work for you in your lab. It's certainly good information, and there's a lot of good people doing a lot of good research, and we all need to learn from that, because we can't do it all ourselves. But I still think you should validate it in your lab for your patients, because that is a difference.
Perfect. Thank you.
A question that it's made here over the right, Alicia Benet. There are differences between oil of the companies, of the different providers about storage. For example, watch out the light, or watch out the temperature, store at room temperature, or store at fridge. What can you tell us about these differences? Is because the paraffin oil versus mineral oil, or I mean, it's the composition of the oil, or why is these differences existing? Spanglish.
I got it though. Honestly, I have not researched competitors' oils greatly. My feeling is that there are certainly papers out there that I'm sure support everything they do. I know some oil comes in dark bottles. I know some is told to be stored in the fridge. And my guess would be that they have their own validation studies to support that, or they're basing it on research studies that they have. Honestly, I can only speak for our oil and just know that, you know, the studies they did, the light coming in didn't seem to matter. It's another one of those things where I believe most people will store it in a dark cabinet anyway, because
just
why not? Yeah, exactly. I mean, nobody stores any of their stuff, you know, out in the sunshine or anything like that. So, and it could just be that they want to take that extra step. They want people to feel good about the product they have and what they're using. And that was the step they felt necessary, you know, for their product. I can't really say. But again, I don't think you do any harm storing any oil in the dark versus, I mean, I don't know anybody who stores it in the light is, I guess, the bottom line. But as far as refrigerated temperatures versus room temperature, I'm unaware of any definitive study that says there's less breakdown at, you know, refrigerated temperatures versus room temperature, that kind of thing. But what their internal data showed could require that. I'm not really sure.
Okay.
Here's another question from Fernanda Raffo. She's asking about what's your recommendation about the time of the oil being at 37 degrees?
That's a good one. So I think it depends on, so this is me personally. We don't have any recommendations company-wide. I would probably say a day or two. We always aliquoted our oil. I would recommend that for pretty much everything. You know, I don't know anybody, again, who puts a whole bottle of media in an incubator and leaves it there until they're done. You know, a lot of the big concern with that was when people used glutamine in media and it broke down to ammonia. And that's a big problem. Obviously, that would be increased at 37 degrees. Now, as far as I know, all media uses L-alanine glutamine. It doesn't break down into glutamine, so we don't have that same ammonia problem. But it's one of those things where if we can aliquot and use X amount in a couple of days, why wouldn't we? It's not that much more difficult, you know, to aliquot media and use up everything either every day or every couple of days. So I would say every day or every couple of days, if for no other reason, that would make me feel better. I can't quote a study right now that would say that's absolutely imperative, but it's another one of those things where it's not that difficult to do. And if it's going to help the patients, why wouldn't we? So
you recommend in an extended culture to day 5 to change the oil, to change the plate, the culture plate?
So that's a good question. So no, I guess I'm talking in addition to those. I mean, we have people who culture in day 7 and don't change the dish. So I know it's fine for day 7. And I guess that's my point, is if you culture it 5 days before you even put it on a dish, and now it's in a dish for 7 days, now you're talking 12 days. For me personally, that's a lot. I would rather, you know, add a day, maybe 2, onto that 7 days, and I would feel confident in that. But yeah, having it in an incubator for a week pre 7-day exposure would make me nervous. Now, again, do I have data to support that? No, that's my personal, that would make me nervous having anything at 37 degrees for that long.
Okay. Lisa, I have a question about that. It's not the main topic, but I think it's really important about your opinion about the time to denudation and injection. What's your opinion about that? Do you think that we have to do a longer pre-incubation of the oocyte before denudation, or do the denudation fast and injection, just after that?
So again, I hate to say, but that depends on a lot of things. I would probably look at stim, and I would look at what you're expecting to get. If you she took her trigger wrong, or you're expecting more immature eggs, she had a very rough stimulation protocol, I would probably leave the cumulus cells on a little longer. Because the cumulus cells, there's such interaction between the oocyte and the cumulus cells, and the longer you can leave them in that environment with those cells on, the better off they'll be. And I guess I'm inferring from that the more likely they would be to pop a polar body if they didn't already have one. Whereas the minute you strip them and remove all the cumulus cells, that in and of itself becomes stressful. And so certainly I have seen eggs that have been stripped that have still then popped a polar body. But I feel like they are better able to adjust to their environment. They're better able to deal with pH changes, those sorts of things with the cumulus cells on. Okay. So if at all possible, I would leave them on, until you're ready. Now, the flip side of that is, again, if we go back to your 10 ICSI day, and each case has 20 eggs, and you can tell maybe by the looks of the cumulus, they're expanded, they're very pretty. Okay, maybe you strip and go. I've done both, quite frankly, many times, depending on the stim situation, the eggs, what I think they look like with the cumulus on, how many other things I had to do that day, is sperm ready, that kind of thing. And I think it's a much bigger picture than just one saying, okay, they must be left on every time for 2 hours before you ICSI. I don't think it's quite that simple to say. I have done it literally retrieval, strip and go and been fine. I have also let them sit because I was afraid many of them were going to be immature and, waited for 5 hours because I wanted more of them to mature. So.
Perfect. Thank you.
Yeah.
I don't know. I'm just dry of questions.
Oh. That's a good thing, right?
I have just one more, but it's, just if you can answer about your opinion about the hyaluronic acid instead of PVP. Do you have any experience about that?
I don't. I saw that. And what was the PVP or what?
The hyaluronic acid.
Ah, yeah. I have not. I guess I didn't even know that was a thing, that people are using hyaluronic acid instead of PVP.
Mm-hmm.
Interesting. See, that's brand new to me.
Yeah.
Yeah.
I think it's a very high concentration. I don't know, but I have read very few reports about that. But
and do they say there's a benefit?
No, they think that it's more natural.
Yeah. That makes sense.
Yeah.
Maybe it's organic or something.
Yeah.
Like
Yeah.
These new waves.
That's right. Yeah, I don't know. I'll have to look into that. That's really interesting.
Mm-hmm.
So, I mean, is it common that you guys use PVP down there?
Yeah.
Yeah.
It's for sure. Yeah.
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 There's no other thing.
Right,
For
yeah.
like this.
Yeah, maybe you're on the cutting edge there, Christian.
Well,
very good.
I think
say Alicia,
questions or no, any extra comments or no? I think we covered a lot of topics, but
That's great.
No. So, well, thank you again to all of you, Lisa, Christian, and Ignacio. I think it was a very interesting and rich exchange and productive. So, thank you once more. And maybe we will get some extra question afterwards, so we can keep it and forward you both to you, Lisa, or also Christian and Ignacio, just to discuss and get a final answer, and we can deliver to people again.
Yes, that'd be great. Reach out anytime. I'm happy to help.
Okay. Okay. Well, thank you once more. Thank you to SAEC, also to, well, I will speak in Spanish now.
nice.
No, gracias nuevamente a SAEC por el auspicio de este webinar. Gracias a todos, gracias por la gente que nos ha acompañado. Reitero nuevamente lo que estaba diciendo recién, que si alguien se quedó con alguna pregunta para poder hacer, será bienvenida. Se la remitiremos a Lisa, a Cristian, a Ignacio, para poder darles una respuesta ya terminado y ya pasado el webinar. Otra cosa que les quería comentar a todos es que el webinar va a quedar en algún momento disponible en YouTube también para que lo quiera volver a escuchar o para invitar al resto de la gente que no pudo unirse a nosotros hoy para que lo puedan poder compartir luego. Así que, bueno, acá lo tengo a Daniel también, no sé si lo dejamos para que también pueda decir algo.
Bueno, buenas tardes a todos y, bueno, más que nada, acá hubo mucha gente en el escenario, que ya vieron todos. Desde ya, Cristian, Ignacio, los agradezco muchísimo, es un lujo tenerlos en el webinar. Y bueno, ahora tengo que agradecer mucha gente que estuvo detrás del escenario, tanto como Martín Leonetti, nuestro streamer, un genio. Bueno, Alicia, mejor imposible. Y voy a seguir en inglés porque tengo que agradecer los de afuera que no entienden lo que estoy diciendo. Now, I've been, this is for Lisa and Ken. Ken, you are backstage, but we thank you for your great support in this webinar. Lisa, invaluable contribution. It was great. And thank you for speaking so slowly. Everybody So from VITAGEN, we thank everybody and hope we will continue with these webinar presentations. And thanks again to everybody. Bye-bye.
Thank you.
Thank you.
Muchas gracias. Thank you, Lisa.
Thank you,
Ken.
guys.
Thank you so much.
Bye.
Thank you. Gracias. Nos vemos.
Gracias a todos.
See you. Bye-bye.